Okay, task 2 for section 15.1, multiplying monomials. So here we're going to be introduced to algebra tiles. So here we have an algebra tile diagram that represents the product of two monomials. Okay, so one thing I want to talk about the key over here for a minute. Any of these yellow, and I'm going to actually start at the bottom of the key and work our way up. Any of these yellow bars are of length x. And if it's yellow, it's positive. If it's red, it's negative. So these yellow bars would be 1x's. These negative ones would be negative 1x's. So then if I create a box that's x in length, so this is x long this way and x long this way. So this one ends up being x by x, which is x squared. Okay. So this one is again, so now the red box is x in length and x in length. So x by x, but it's negative x squared because it's red. The reds are negative. Okay. So if I multiply this positive by a positive x by a negative x, I'm going to get a negative x squared because we know positive times negative is negative. Okay. All right, so to show this multiplication, how these work, okay, to make sense. This guy right here is not an x. This is just showing us that we're multiplying. That's a multiply, okay? So here we look at, it's kind of similar to our arrays from back in like 3rd and 4th grade. If I was multiplying 3, I would have this 3 in length. And then let's say multiplying by 4, this one would be 4 in length. So inside here, I would have a box that's 3 by 4, which would end up giving me 12 inside, right? So it's really just stemming off of that array idea, okay? So this length is 2 x's. It's x from here to here and x from here to here. So that whole length is 2 x's. So it says, what are the two monomials whose product is multiplied by the algebra tile diagram? Well, we know one of the monomials is 2 x's because this guy right here is 2 x's long. This one is 1, 2, 3 x's long. So the other one is 3 x's. So I'm multiplying the 2x and the 3x. So what is the product of the two monomials? So very similar to what we did here. This one's 3 long, this one's 4 long, so inside is 12. If this one's 2x and this one's 3x, inside, each one of these is an x to the second. And so I end up with 6 of them. 1, 2, 3, 4, 5, 6. 6 x to the seconds. Okay. Okay, which is what I would get if I'm multiplying 2 times x times 3 times x. I can multiply the 2x and the 3x, which is where that 6 comes from. And x times x is x to the second. Okay, it's just a visual way of showing that multiplication. Okay, let's go ahead. Let's look at the next one. What are two monomials whose product is modeled by the algebra tile diagram? What is the simplified product? So let's go ahead and look at one side. This side here is 1, 2, 3, 4 x's, and they're positive because they're yellow. This side is 2 negative x's, so negative 2 x's. Those are the two things I'm multiplying. And so inside, each of these is a negative x squared. So I have 1, 2, 3, 4, 5, 6, 7, 8. So when I multiply them, I get a negative x to the second, which if I take 4 times x times negative 2 times x, 4 times negative 2 gets me that negative 8. X times x is x to the second. Okay. Now, can you use algebra tiles to find the product of 3x times 4x to the second? Well, I can for sure do the 3x's, right? If we were going to go ahead and create one, I'm going to kind of do a little one. We would have 3x bars. So there's 1x, 2x, 3x's. And I'm just drawing my bars as lines. I guess we could draw full bars. 1x, 2x, 3x's. But I would need 4x squareds on this end, so that would be a squared. Okay, but how do I do the multiplication in the middle? Because I would need to take an x squared times an x, which would be an x to the third. I would need cubes. I would need to draw cubes like a 3-dimensional cube, which we can't draw on flat paper. So can you use algebra tiles to find the product of? No. It ends up being, it needs to be 3-dimensional, right? It needs to be 3-dimensional, which we can't get those to be 3-dimensional. So no, it would need to be 3-dimensional to be able to do that, and we're just dealing with a 2-dimensional paper. We don't have any x cubed blocks. There are no x cubed blocks. So no, it would need to be 3-dimensional. We would need x cubed blocks, which we don't have. There are no such thing as x cubed blocks.